Anyway, so we get started here about slope. Like I said, the unfortunate part, the intercept work we did yesterday was deleted by accident. So, all right, here we go. I'm going to go over some 4 scenarios here about slope. Okay. Well, let's take a look here. Here's your line, and I know yesterday we graphed lines by plotting intercepts. We reviewed intercepts. We reviewed the those kind of graphing a line from yesterday, plotting points. But again, that video got deleted, so I have to reintroduce that later in this whole thing. So we're still working on the graphing. This is under your graphing worksheet. Okay, so you want to take a look at that graphing worksheet. This is a very important topic in algebra. You guys have to leave here graphing like, you know, in your sleep, being able to do this stuff. So we're going to go over some of the work. But today, I mean, last time I talked about intercepts, lost the work. Today we're going to talk about what? The slope of our line. So we started a little, at least in the other class we talked a little bit. Let me demonstrate to you guys a couple of things. Remember yesterday we talked about how many points are on a line anyway from yesterday? Infinitely many points are on your line. Is that true? So I'm going to take just 2 points on that line. The address of this first point, though, is at x1, comma, y1. So here's the address. The address of the second point, though, is at x2, comma, what? y2. So let me point this out to you. You got one point at x1, y1. You got another at x2, y2. You have 2 points on your what? Line. Okay? So, okay, fine. What I'm going to define for you guys is this. If I were to know, by the way, can you measure the distance between x1 and x2? Right? How do you measure distance between x1 and x2 if you had a ruler? Just to kind of remind you guys that I find that sometimes students aren't really able to use a ruler as well as they should. So let me show you what I'm talking about. Okay? That if you have an object that has a, who knows what your object is? Here's your object. And that object, I don't know, is that a pretzel or something? I don't know what it is. What is that, a worm? Let's say it's a science class, you're measuring the length of a worm. Yeah. Let's say this is at, remember, you don't always start at the edge. So you may start at this, if this is in inches, maybe this end measures what, 3 inches, and this end over here, let's say measures what? 8 inches. You okay with, you see what I'm saying? Do you guys know, how long is that worm in science class?
5 inches.
5 inches? How do you know?
There's 5 numbers in between.
Well, you guys know how this measures 5 inches? Because you took the 8 measurement on the right, isn't that on the right? And you subtracted what? 3, and you say, okay, 8 minus 3 measures what? 5, so you can deduce that the length is really what? 5 inches. You okay with that? Moral of the story is that when you measure horizontal distance, what are you really doing at times? You're taking that number and this number and you're what? Subtracting. So here's what I'm saying here for this picture. That this horizontal distance here that I want to measure from x1 to x2. What's this length? Do you guys know? How do I find that length? Well, isn't that length the same as this length? Say yes.
Yes.
Okay, good. This length is the same as this length. Well, what do you think? How do I determine that length? What do I do? Take x2 and what? Minus what? x1. You okay with this? You guys okay with finding that length this way? That concept of deducing length is what you're using here when you have a ruler. This is your ruler, and you're trying to measure how long that worm is. By the way, we call this distance, we call this the run. just so you guys know. That's our run. So run is the horizontal distance between these two locations. It's going to have valuable information for us. Stop and think about this. If you were to take another worm, another object, but you actually were trying to measure how long this really was. You got out your ruler, right? Is there any law that says when you measure how long something is, that it has to be placed horizontally? Or could you measure how long something is vertically? Could you do it vertically as well? Yeah. We measure our height vertically. So let's say you got another worm, another object. This is your science class. And you are trying to measure how long that particular worm is. You don't necessarily start at the end, do you? What if this measurement, and I'll put this in red. What if that was a 2, and this measures a 9, for example? Okay, you didn't start at the end with putting the object down here. You started at 2 inches, I guess. And then you've seen, oh, at 2 inches you have one at the bottom there. At 9 inches is the top. What would you guys give? What's the answer for the length here of that worm? How do you know it's 7? Because what did you do? 9 minus 2 is what? 7. That's the length of this worm measured vertically. Is that true? You guys okay with this? Okay. Well, here's the deal. If we want to measure, by the way, this distance in red, I know, for example, that the top is called Y2 and the bottom is at Y1. So I'm trying to measure, and tell me if you agree. Is that distance the same as this distance over here? The answer is yes. My question to you is, what is this distance? Because that's the same as this distance. What is this distance? How would we measure that distance? What would it be? Y2, good. Minus Y1. Ladies and gentlemen, we call this the what? The rise. So there's two quantities we're concerned with. The rise and the what? The run. We're concerned with this because, and I'm going to erase this here. Because what we call the slope is really the ratio or the fraction of the rise over your run. Okay? It is the rise divided by run, which is the definition of what we call a slope. So I want to put some details here. What letter do we use to represent the slope? Do you guys know? We're going to use the letter M. M represents the slope. So M here is going to be, how do we measure rise again? Y2 minus Y1. Y2 minus Y1 over, how do you measure the run again? X2 minus what? X1. Okay, this is what we call the slope formula. Okay, so you have a line here. And let me actually go over some more details here, just so you guys know. You see this line? Okay. Is that, if we walk from left to right on this line, here we are, we're walking left to right. How are we walking? Is that uphill? Good. This is what we call an uphill scenario. You're going what? Let's say that's uphill. Well, let's kind of think about this. if we're moving from this point to this point uphill on our line, right? I'm running in what direction? Isn't that going in the right direction? What direction is toward the right on your x-axis? Is that positive or is that negative? Positive was to the right, negative was where? To the left. You okay with that? So your run, I'm going to say in this example, is going to be what? Positive. So when I measure my slope, I know that it's rise over the run, just to point out to you guys, that my run here is positive. Good. Let's see what's my rise. From here to here, I'm going what? What direction is this? Up. That's a vertical direction. Y measures your vertical direction. Up is what sign? Is that positive or negative? Positive. Down is what? Negative. So this is a a positive rise over a positive run. What's positive divided by positive? So my slope is positive. Is that true? We describe a slope being positive as being, we say the slope is greater than 0. That's another way of saying your slope is positive, okay? Because every number greater than 0 is positive. So I just want to let you guys know this is a positive slope. All right, you okay with this? Yep. Now here's what we're going to have to do. For example, I'll write it down here. They're going to say to you, determine the slope of the line contains the following 2 points as an example. 1, 8 and 6, 9. Okay, so anybody know, what do you use to find the slope when you're given 2 particular points? What do we just go through? Here's 2 points. A point consists of an x-coordinate and a y-coordinate. X-coordinate, y-coordinate. We call this one the first point. We call this one the second point. So we're going to use what's called the slope formula. Is that true? You guys okay with that? Okay. So let me ask you, which point is the first point and which one is the second one? Because they didn't tell you, did they? They didn't say, they just said, here's 2 points. Did they tell you which one was the first one and which was the second? What do you guys think?
I decided 1 and 8 is the first one.
Okay. Why did you make that? Why did you decide that?
Because it's the first one.
Good. That makes sense to me. In other words, you read left to right, and you may say, this is my what? First point, and this is my what? Second point. Okay? Because you read left to right, and you go, oh my God, that's my first one I've read. This is the second one. They're not going to tell you, hey, this is the first and second point. You have to make a choice. And the truth is, it doesn't matter. Okay? But you want to be a little consistent with what you do. Is that right? Okay, so it doesn't matter which really one you call the first and the second, but what I do is if I read it left to right, and I'll say here's my point 1, here's my point 2. I don't like to complicate my life. Point 1, point 2, does that sound okay to you guys?
Unless you're a Japanese.
Right, and then but they actually read up, don't they read top? Don't they read top down, yeah, Japanese?
That's vertical, yeah.
Well, I have enough problems with English, so I just keep it simple. All right? English is the only language I know. So I still like to keep it what? Simple. All right? So here's what I'm going to say to you guys. If you ever have to determine the slope, and how do you know you have to determine the slope? They're going to tell you. If you ever have to determine that slope, they're giving you 2 points. What do you use always? Slope formula. So in other words, and I'm going to recommend to you guys again, every time you use a formula, you what? You write it down. So m equals y2 minus y1 over x2 minus x1. So if you do 20 homework problems determining the slope, you wrote it down 20 times, that means you've learned really, you're actually reinforcing that slope formula. And you're learning how to spell that slope formula, which is important because on a test, maybe you're a little nervous. You already have enough, kind of stress on the test. You don't want to start to think, okay, what was that slope formula again? Let me see. You want it to be automatic. Okay, so when you write it down every time you use it, you make it automatic for yourself. Okay, and I'm going to go through this problem the same way I went through this when I originally did this. I still do it to this day. So even when I show you how to do it, I want to go through these steps. Meaning, here's my formula. What do I do next? I go back and I read what I have. Do you guys remember the first coordinate value, is that an x coordinate or a y coordinate? That's x. The second one is y. Is that true? The first one is x. The second one is what? Y. So what this says is, this number 1 is the x coordinate for which point? The first one. So this means x1 is the value what? 1. Everybody okay with that? And this is my y coordinate value of which point? First one. So I'm going to say y1 is the value 8. Is that true? You got now the second point. The first number is the x coordinate of the second point. So that means that x2 is what? 6. This y, this 9 is the y coordinate of the second point. So that means y2 is 9. When I first learned this, yes, I would write it all down that way. Okay? And then what you do is this. What do you guys do? Plug it in. Replace those letters with the values. Meaning, what's the value of y2? 9. It's right here. What's the value of y1? 8. It's right here. What's the value of x2? 6. It's right here. What's the value of x1? 1. So I go back and plug these values in. Your slope's now going to be 9 minus 8 over 6 minus 1. What's my slope now? What's 9 minus 8? 1. What's 6 minus 1? 5. Do you guys know the slope is 1/5? What that means is the rise is 1 and the run is what? 5. We'll use that in the future, not today though. I'm just going to point it out to you today, but we'll use that in the future. Okay, everyone okay with that? Do you also know that the slope is positive? Is that a positive number, 1/5? It's a positive slope. So what does that mean about the line that contains these particular points? That's what kind of scenario? That's an uphill scenario. You guys okay with that? Now, I told you, unfortunately, yesterday, I somehow by mistake deleted the video we did on all the beautiful work we did on the X Intercepts and Y-Intercepts. Isn't that horrible? We did a lot of wonderful work yesterday. It's gone forever.
You erased it?
Yeah, I erased it by accident, I guess. Darn it. Darn it. I don't know how that happened. It's just not on my computer this morning. Like, where are you? It's not there. I have to do it again, but I have to do it again in a different way. I won't do it again today. We'll review in the future because we need to use that information. So anyway, let's pretend it was yesterday, or not pretend. Let's say what? What did you guys think about yesterday? How many points yesterday did you need to graph a line?
2.
Good. So I'm going to say note. Let's note the graph that contains these 2 points, meaning that graph again was a line, okay? So let's see what this line looks like. Since all we need is 2 points, we got 2 points. So let's be careful here. I'm going to draw my, my x-axis. I'm going to draw my y-axis. Okay. Let me know when it turns off again, because it will. Okay, let's see. What do we have to do? What did we plot yesterday? I know yesterday we plotted intercepts. Today, these are not intercepts. These are just regular points. So how did you guys plot? Remember, you always start at the origin. The origin is where the x and y axis intersect. It's right there. So if you had to plot 1, 8, where is that location? X is 1, y is 8. What do you guys do? For the x value, start with the x value being 1. Is 1 positive or negative? Positive. So 1, positives to the right, negatives to the left. Positive is up, negatives down. So 1, 8 would be, start at the origin, go 1 to the right, and then go how? 1, 2, 3, 4, 5, 6, 7, 8. That altitude there is 8. This is 1, 8. Okay? Did you guys get the graph paper?
Yeah.
Good. Did you get the ruler? Good. Okay, you like your sanity. You want to preserve your sanity. If you want to be crazy, try it without a ruler. Try it without some graph paper. You're going to have to be very careful. Not so easy to do. You can't. Some people can. I'm not one of them. Some people can. I want my graph paper and my ruler. Okay, what's the second point? X is 6, y is what? 9. So I'm going to start from the origin. They're both positive. So for the x, it's to the right, and for the y, it's up, because they're both positive, right? So you got to move to the right how many spaces? 6. So I go 1, 2, 3, 4, 5, what? 6. This is 6 to the right. And then I have to go how many up? 9. Now let's think about this. Isn't this 8 already? Okay, so here's 8, right? Let's have to go one more, which is 9. So this location will be 6, 9. I'm not the best artist, but if I had graph paper, it'd be much better. Going to get out my ruler. So look at this. Even with the ruler, I got to be careful. And really, I want to let this go a little farther. But, Anyway, I'll call this scripted L for line. What's the point I'm trying to make here? Is this an uphill scenario? Yes, it is. Is this uphill? Do you guys notice what's the difference here between this length and that length? This, my run is what? 5. And my rise is what? 1. Okay? So I want to point out to you that this is consistent. 1 over 5. Rise over run. That's 1/5. So from going to this point to the next point, it has a slope of 1/5. For every rise of 1, you have to run 5. We'll worry about that some other day. We're just trying to use the slope formula. But I want you guys to verify that the positive slope is in fact an uphill what? Graph, an uphill line. Okay, and that line contains both of those what? Points. All right, you guys okay with that? Okay. Anybody have any questions?
No.
No? Okay, good.
I remember this from high school.
Good. It's back. It's back, okay?
Like everything under the line, you can't. Under the word line.
Oh, we missed the second point. Let's adjust everything. Thank you. We got to hire you. You got to be my producer.
Okay.
Okay? We got it. Does that even look in focus? You guys okay with that? So, thank you for informing me. Let's go over that. That second point is at 6, 9. To go from this first point to the second point, it's uphill. Slope is positive. Notice the run is 5 and the rise is what? 1. The definition of your slope is rise over run, so that's why it's 1 over what? 5. Okay, good. Thank you for... Thank you. Okay, you guys okay with that? Okay, now we have to look at a what? Downhill. Lines could go downhill. They're not always uphill. They go downhill. They actually do a couple of things. So can I erase this? You guys okay with this idea? Okay. So I want to point out to you that you can have a scenario that's very similar here. We're going to look at this slope formula. But this time I want to draw a picture of a downhill situation. To point out a few important ideas. X axis, Y axis. Okay? Positive and what? Negative. Positive, what else? Negative, okay? So let's draw that downhill picture for you. Okay? Here's that scripted out line. You got these 3 lines here, okay? X-axis, Y-axis. Here's your line. Let me know if it goes off. We might be okay. Okay, let's take a look. Let's say this is my first what? My first point again. It's at x1. Okay, and it has a corresponding y value at y1. So the address is x1, comma y1. And then here maybe, over here maybe, is the second point at x2. And here's y2, so the address here is x2, comma y2. Okay. Now, what is our slope again? What do we say our slope is? Rise over what? Rise over run. So I'm going to put this in red, my rise, and put in blue my run, just to emphasize this idea. This again, we're walking from left to right. We're going to call this a what? Downhill scenario. Okay, does everybody agree that that's downhill? All right, let's take a look here. So what I'm going to say to you is this. If I go from this point to this point, right, I'm really going how? Here. And then I'm making a quick right and going where? Over here. So in other words, and I'm going to put this in blue, by the way. Bless you. What I want to point out to you that your rise and run, by the way, is still the exact same formula, y2 minus y1 over x2 minus x1. That does not change. But what I want to point out is a couple of things here. Your rise is going how? You're going, is that going up or down? Now this is a vertical distance. We know vertical down distance is negative or positive. So this portion is going to be negative. My rise, I'm going to say, is negative. I just want you to pay attention to the signs. Are you still running to the right, though? Yes. The right direction, horizontal direction, if you move to the right, that's what? Positive. So you now have this rise that's negative and the run that's what? What's a negative divided by positive? Is that negative? Okay, here we go. Now that we're squared away, why is the slope negative again? Your rise is what? Going down. Down, vertical distance going down is negative. You're going in the negative direction. Going to the right, horizontal distance is positive, so negative divided by positive is going to be negative. So I'm showing you that your slope's going to be negative. Let's verify that by giving you a what? An example now. So I'm going to give you another example here. This time your slope's going to be not positive, but what? Negative. But negative, so you guys can see how that works. And then of course we're going to graph this. So, all right. Let's look at this example. Negative 4, 3. And what else? 2, negative 6. Okay? So, again, let's see what's going on. We're going to determine the slope, and we're given 2 points. Which is the first, which is the second? Doesn't matter, good. But I'll call the first one I read on the left, point 1. I'll call the second one what? Point 2. Okay? And then this is the x-coordinate of the first point, because it's the first number. That's always the x-coordinate. The second number is always what? The y-coordinate. First number here is your x-coordinate. Second number is your what? Y-coordinate. Okay, so like I said before, what you're going to do is every time you use the slope formula, you write it down. So that guarantees that you learn how to use that formula. So it's going to be m, which represents your slope, is y2 minus y1 over x2 minus x1. Okay? So then now go back, and I would say to you, go back and read what you have. Meaning, what's that first number again? Could you guys tell me what is x1? Why do you know that's x1? The first number is in the x-coordinate position of that one first point. So that's x1. So that's negative 4. Okay, now what is y1? y1 is the second value of the first point. So y1 is what? 3. What is x2 going to be? What is x2? 2. And then what is y2? Is that negative 6? Okay, you guys okay with that? So I'm go through this procedure. Every single time you do these problems, go through that procedure. Write down the first point, the second point, x, y, x, y. Write down your slope formula. Verify what everything is. And then what you do, what comes next? Plug it all in. You have to determine the what? The slope. That's the value of m. That's what they want you to find. So plug this in. Let's see. What's y2? Good. What's y1? 3. Good. What's x2? 2. What's x1? Negative 4. Go back and double check if you have to. Double check. Is everything okay? Looks like to me. All right, here we go. My slope will be negative 6 minus 3 over 2 minus a negative 4. Don't think that because that number is negative, that takes care of that negative sign. No, it isn't. They didn't know that this number was going to be negative. It could be positive or negative. So if that negative sign is already there, keep it there. You okay with that? Okay, good. Now, here's what I'm saying. This is where signed arithmetic comes in. Math 110. What's negative 6 minus 3? Is that negative 9? Okay, good. Didn't I tell you that the rise is going to be negative? I did. What's 2 minus a minus 4. Wasn't this also 2 plus 4? Because that's what minus the minus is? What's 2 plus 4? 6. Remember when we were reviewing all of these fractions that are negative, what did I say for you guys to do with that negative sign? Put that negative sign where? At the same level as your division sign. And now you have 9 over 6. What does that reduce to? 3 over 2. So ladies and gentlemen, I'll put your slope here. The slope is negative what? 3 over 2. Is it true that you have a negative slope? Yes. You guys know what that means if your slope's negative? That when you plot these 2 points, because all you need is 2 points to draw a line, and you draw the line through the 2 points, it's going to be what? Downhill. How do we verify this? Let's graph the line that contains the 2 what? Points. Okay, you guys okay with that? All right, here we go. Let's draw this line. Again, this is your x-axis, and this is your what? Y-axis.
Will they ask for that? Once you get the slope, will they ask graph it too?
Sometimes, yeah. We got to be able to do both. And it's also like a review from yesterday. We reviewed plotting points, but those points were special yesterday. Those are intercept points. So again, today it's a good review to be able to do what? Plot points, and then draw your line. Because what's going to happen in the future, we're going to give you that equation of the line, and you got to graph it, and you got to spit out the graph. And that's a process. Okay, so what you guys are learning really is a processes. Now stop and think about this for a second. This is an important skill. I'm going to remark about this skill. You know, there's processes for everything. I think we talked a little bit about that. And so when you go to college, you still want to be able to be somebody who can follow somewhat set of instructions and directions, because wherever you go, you're going to face processes. Even if you say, "What do you mean? I want to major in nursing." Well, there's the mathematics behind the science that you're studying. That's a separate issue. But what I'm focusing on, the comment, is that you're going to probably, even in any field that you go into, have to be able to follow a set of instructions and processes. What happens when you can't? You got a problem at work, don't you? Yeah, they'll fire you. Can't follow the processes, protocol, instructions, right? So what I want you guys to focus on when you do these problems is the fact that you're following a what? Process. Identify what point is first and second. Clarify what each one is and use your slope formula with some arithmetic. You can find the slope value. But then remember what the context of all this is. It's in graphing. So if they ask you, and they may, can you graph that line that we're talking about that has a slope of a -3/2? Yes. Let's follow up. The x-coordinate's -4. The y-coordinate's 3 for my first point. How do I plot that point? Let's review plotting. That's another process. Which one do you start with again? The x-coordinate. And where do you really start always? At the origin. Is that true? So you move from the origin to, where is x negative? It's to the left. Is that right? On your x-axis. I have to move to what number? Negative what? 1, 2, 3, 4. I got to go all the way to -4. And then what's the second number going to tell you to do? The y-coordinate value is 3. Is that positive or negative? What direction's positive for the y-coordinate? Up is what? Positive. So I have to now move up how much? 1, 2, 3. There's the location. So this point is -4, 3. That's the address. So notice even plotting a point, you follow a what? Procedure, a set of instructions. Now, what about the next point? 2, -6. How do we get there? From where? So we're reviewing again the plotting points from the origin. We got to go where? Well, where is 2 located for the x value? Is that to the right or to the left? To the right. So I have to go to the right 2 units. Okay, so I went to the right 2 units. And then what do? Go up or down?
Down.
How do you know it's down? It's negative. Negative is where? Down on the y-axis, negative direction. So I have to go down how far? 6 units. So remember, I first started from the origin. I went to the right 2. Now I go down 1, 2, 3, 4, 5, 6. This is really at -6, by the way. This address is 2, -6. What do I now do with those 2 points? Draw my what? Line. You get out your ruler. It's what you got at the 99-cent store. Okay, so now draw your line. Here's the line. You guys ready for this? Here's my line. What do you guys notice? Is that in fact downhill? That's a downhill scenario if you're walking downhill. Okay, is that a pretty steep downhill scenario? I don't know if I'd want to walk on a slope like that. What if you tripped? You'd go down forever. Now, I want to remark though, my scale here might be a little flawed though. Okay, I admit that. I'm not the best artist. That's why you get what? Graph paper. So you help yourself out. You can really take a good look at this. But slopes are everywhere. There was a slope that you used to get in this room. Is that right? And why do we have a slope? What's that for? Yeah, in case somebody's in a wheelchair, you can still get in the room. Okay, if somebody's in a wheelchair on that kind of slope, is that a problem? Sure is. Okay. All right, so this is a negative slope scenario. You guys okay with this? We got a couple of exotic situations to talk about now. Okay. Anybody have any questions on that? What do you do later on today? Work on your what? Your slopes. Like you worked on your intercepts yesterday, hopefully. Okay? Can I erase this? You guys have this here? All right, let me erase all of this. Let's talk a little bit about some exotic. I'm not going to say this next example is not really very exotic. I should have kept this up. Darn it. All right. This next scenario is not very exotic. But I kind of think of it that way in some ways. It's just a little different, okay? So, here's what I'm saying to you. Right? Since we're talking about slopes, slopes are everywhere. My y-axis, my x-axis. Let's think about this scenario. Here's my line now. Do you guys know what kind of line is this?
Parallel.
Well, all right, okay. I buy L is parallel to X. Okay, good. That's true. We'll write this down, by the way. L is parallel to X. Or the line is parallel to your x-axis. Good. What else? Good. This is a horizontal line. Is that true? So I'm going to point out that fact and say to you that this is horizontal. So if I were to plot, for example, let's say this point is the location of x1, comma y1. My first point. Everybody agree with that? And then over here, I have x2. This location is x2, comma y2. But what do you guys notice about this? y1 is the same as y what? 2. They have the same y coordinate values. Now, I erased this portion because I said, okay, my slope was, we said, a rise over a what? Run. Rise over run is the slope. This distance here is that my run or my rise? In other words, if I start at this point and I go all the way to the next point here, to the right, by the way, and I know that's positive, the point I'm making is my run is that x2 minus x1. And I know the run is what? Is this positive? Yes, because we're going to the right. Positive, right? Positive direction. Okay, good. Now, from going from here to here, am I running anywhere? Am I going up or down? No. What is your run then going to, or your rise going to be? If I went from here to here, did I have to rise to get here? No. So we're going to say the rise is what value then? 0. So my slope, ladies and gentlemen, is going to be that 0 rise over some value of run. I don't know what it is, but it's some value. I don't really need to know what it is because what's 0 divided by any value of run? Good. 0 divided by any number is what? So my slope here for the horizontal situation is 0. So if you're walking, this is probably the best scenario. Would you guys agree? Is that the best scenario? Why is that the best? The slope is what? 0. It's not uphill, positive slope. It's not downhill, negative slope. Is downhill a problem? Do you guys know you could get hurt going downhill?
Oh, yeah.
Anybody go hiking? I got my pictures. I'll show you. Can you get hurt going downhill? Okay. In some ways, going uphill it's harder, but going downhill you got problems too. What about this? That's the best scenario. This is what I say is the best. You guys know what the best is? Slope is 0. Sometimes we say there's no slope. Some algebra books call that no slope. Okay? I call it slope equal to 0. Best situation. Well, do you guys have lines that behave this way? Let's give you an example. Determine the slope of the line that contains these 2 points. Two, 4, and negative 3, 4. So here's another example. Let's see. Do you guys know which one is the first point, which one's the second? Doesn't matter, but I'm reading this 2, 4 first. I'll call it first point. I'll call this the what? Second point. Okay, you guys okay with that? So, what's your slope formula? M is y2 minus y1 over what? x2 minus x1. Every time I use it, I write it down. What comes next? Let's verify what each value is. First value is always the x-coordinate value. So x-coordinate, x-coordinate. Second value is always a y-coordinate, y-coordinate. Let's verify. This 2 is x what? x1 is the value 2. The 4 is really what? y1. Good. So y1 is 4, while x1 is 2. Is that true? All right. What is the x2? What's x2? It's negative 3. What's y2? y2 is 4. What comes next in your process? Plug it in. Okay, good. let's see, y2 is, what is that again? 4, what's y1? 4, x2 is -3. Okay, x1 is what? 2. Let's see what the slope is. Well, if I continue here, let's say, what's 4 minus 4? It's 0. What's -3 minus 2? Well, be careful. What is this? Let's see. Isn't that 0 over, what's minus the -3 minus 2? Is that -5? Is that right? So, what's 0 divided by -5? Is that 0? Is that true? Incidentally, let me go back to this comment here. You go, oh my God, I thought you said this was going to be a positive. Because my first point is on the left, the second point's on the right. This picture, because that's negative, that's going to tell me that this first point, where is it at? That first point is going to be to the right of this second point. Let's verify that. Okay, so be careful. Even though the picture I drew has x1 on the left and has this point on the left with x1, y1 coordinate values. It's on the left of the next point. We could have called this one x1, y1, and this one x2, y2. Notice what that would be for the run. It would now be from what? Right to left, and it'll be negative. And that's what's happening with this example. Okay, so I just want to emphasize, in some ways, you really don't even care whether the sign is positive or what? Negative. Doesn't really matter, because ultimately any number, 0 divided by any number that's positive or negative is always going to be what? 0. So your slope here is 0. So just to kind of let you guys know that about that picture. Point being, what do you guys want to think of with the slope being 0? Think of a what? Horizontal line, where the slope is not, it's not uphill, it's not downhill, it's neither. It's just horizontal. That's the best hiking situation. You okay with that? Let's see an example. We did see the example. Let's see what it looks like as a graph. Let's graph this out and see what it looks like. X-axis, y-axis. Okay, what's the first point going to be? 2, 4. Where is that at? Go to the right what? Go to the right 2, and then go up how much? 1, 2, 3, 4. This is the address. X is 2, Y is 4. That's my first point. Is that right? Okay. What's the next point? -3, 4. So I start at the origin. Go to the left. 1, 2, 3. And then go up where? 4. -3, comma 4. So isn't it true that this is still a what? A horizontal line? Okay, let me be careful here. Like I said, my art skills are not the best. Are my lines parallel, you think? Hopefully. So I'm going to say here is going to be where it was. Okay, if I had graph paper, my life would be a lot nicer. It'd be easier. Notice, going from this point to the next point, I had to move where? To the left. I had to move in the what? Negative direction. So what I'm saying is that the picture that I drew here, we don't really care about this, but I want to point it out. Going from here to here, it's a negative value. That's why we had -5. But who really cares? What's our rise? Our rise is 0 because the slope is rise over run. Your slope is the value 0. That's all we care about. Just want to point out that detail. So now we're a little more consistent over here. Because that's enough to kind of freak people out. This is what I call an exotic situation. There's your horizontal line. Okay, you okay with this? You ready for the last exotic situation? What does exotic mean again? Huh? Out of the ordinary. Good. Anybody have an exotic pet? What is it?
I'm just kidding, I know.
You know? What's an exotic pet? Huh? What kind of pet do you have?
Parrot?
You have a parrot?
Yeah.
Is that exotic?
No.
Wait, it talks different languages though.
It does?
Yeah. Some words in English, Spanish, French, Portuguese.
Really?
Yeah.
There's birds that could do that?
Yes,
I thought they only know one language.
well, I guess he's doing it. But it flew away.
It flew away?
Yeah.
So you shouldn't have told it all those languages. Shouldn't have taught it all those languages. Now it has to go to all those places. It's like, wait a minute. I'm going to go practice my French. Right? Jeez. I didn't know that. Really? Your bird can actually speak different languages?
Well, he didn't speak different language, but he said words in different languages.
Really? Does that mean you're a pirate if you have that kind of parrot?
Probably.
Is that what it means? You're a pirate?
Yeah.
All right, well, let's look at an exotic situation. I guess a parrot that speaks 4 languages is pretty exotic. Is there any snake lovers in the room? Anybody here have snakes?
Oh, I hate snakes.
Anybody have snakes? You used to? What happened to them? Died? Snakes die? How hard is it to have a pet snake? Really?
Yeah, and we had like a family of like 5 kids. So they all wanted to play with the snake.
Oh, jeez. God, snakes. I don't know. I've always thought it was kind of weird to have a snake. Do you know those kids that used to walk home from school with sometimes? They had a pet snake. Weren't they always kind of a little weird? No? All right, maybe I apologize. I'm sorry. I just never thought of having a pet snake. But then again, if you have a cat, any cat lovers in the room?
Oh, those kids.
Anybody have a cat?
Oh yeah, I got like 5 of them.
You got 5 cats?
Yeah, 'cause my mom was kids.
Cats are moody.
Hey, but at least you don't have to walk them. They go, you need to use a bed to just go in the butt.
I guess so. You're right.
They say as pets, dogs look up to you, and as cats, cats look down to you.
Oh, really?
Yeah.
What's the best kind of pet to have? None? A what? A dog is the best. I think you're right. I'm a dog person. Dog is the best. Although, don't feed. You know what? If you try to feed your dog McDonald's, what is your dog gonna do? Dog's gonna look at you like, I don't eat this stuff. Your dog will eat McDonald's? Try it out. Try it. The dog's gonna look at you like, that's not food.
A chihuahua?
You have a chihuahua?
He's a chihuahua, but he's like mixed with something I don't know what it is.
Do you guys really like chihuahuas? Do you really like chihuahuas?
They're furry.
You have what?
Well, it's a chihuahua mixed with something, but I call it a chiweenie because
Chiweenie?
it's long like a chihuahua,
It's long like a chiweenie?
but it's like small like a chihuahua.
Oh my God.
A hot dog.
A chiweenie.
The weird dog.
That's pretty funny, a chiweenie. Got a chiweenie. Gosh. Those chihuahuas get in my nerves. Chihuahuas are kind of...
It's just a trend.
I have no idea. I know a lot of people that have chihuahuas and chiweenies that you're talking about. I think I have a cousin who owns a chiweenie. I know some girls that have chihuahuas. They sleep with their chihuahua.
No.
And I would think that if you slept with your chihuahua, what if you're like me, I need a king-size bed because I'm rolling all over all night long. I think I'd roll over that chihuahua. think the Chihuahua wouldn't appreciate sleeping next to me. You know what I mean? Do you sleep with your Chihuahua? Good. Did you get the Chihuahua comment?
Yeah, that's where it cut off.
I'm going to get email from people. I get email. I get a lot of email from people around the world for these videos. Time to get out of here.
No.
Yeah, I get email from people all over the world.
No.
They're gonna get an email. Can I have it? Where do you find a Chihuahua? I don't know. What do you guys think? What kind of line is this? Is that vertical? What does vertical mean? Up and down. It's really strictly up and down. Is that right? It's not even diagonal in any way. That's a vertical line. So I'm just curious. If you were to plot one point over here, this is your this is your x1. Here's your y1. x1, y1. And what do you guys notice about this x2, y2 business? It's the same. So you can say this is x2, y2. Here, the x1 value is the same as the x2 value. So, I mean, it doesn't matter what you call it. Sometimes people call that x. The point being that, again, your slope is rise over run. Well, let's be consistent. The slope will be, well, I think rise was red, right? So we have a red rise. We have a run that's blue. Are you running anywhere? If you go from this first point to the second point, are you running anywhere? Meaning we're not moving left or right, are we? So the run is what value? 0. I really don't care what the rise is, whether it's positive or negative. I don't really care. We call it a rise anyway. It's a value. So what do you guys notice? The slope is going to be what? Some rise value divided by what number? 0. What's the problem here? You can't divide by 0. Is that true? Here the slope is undefined. What is it not to be defined? Do you guys know what is it not is? What does undefined mean? This is a bad scenario. I'm gonna put this situation here. If you're on a vertical slope, you can what? You're falling off that. You're falling down forever. Is that true? You're not walking with a 0 slope. You're not going uphill, downhill. You're falling off the planet. What does it mean to not be defined? What's the worst thing? Uh-oh, what if this camera gets this? What's the worst thing that you can do to a girl? Or I shouldn't say do. Let's say, what's the worst thing that can happen to you in relation to, even if you're a guy? Doesn't matter.
Fall downstairs.
What if you're undefined to some girl? What does that mean? You're nothing.
Yeah.
What if you're a girl and you're undefined to some guy? He doesn't. You're not defined. We're not done yet. Let's look at our example. Let's see an example of this undefined business. Contains the point -2, 1 and -2, 3. What's our slope? Let's go through the process. M is y2 minus y1 over x2 minus x1. First point, second point, right? Is your x-coordinate value, y-coordinate value. The x-coordinate, y-coordinate. What's x1? Good. What's y1? 1. What's x2? -2. Good. What's y2? 3. What comes next in your process? Plug them in. 3, 1. What's x2? Negative 2. x1? Negative 2. Let's see what our slope is. Well, that's 3 minus 1 over negative 2 minus negative 2. Do you guys remember what's minus the minus? And that plus, okay, so then I get 3 minus 2 is 2. Negative 2 plus 2 is what? 0. Ladies and gentlemen, you can't divide by 0. This is a slope that's what? Undefined. Automatically, you should conclude that your line is what? Vertical. How do you verify this? We still got some time. How do we verify it? Graph. And let's double check. Negative 2, 1. Where's that at? X-axis, y-axis. Negative 2, 1. To the left, what? 2. And then up, how much? 1. This is the location of the point negative 2, 1. What about negative 2, 3? Going to the left, 2. And then up, 1, 2, 3. Here's the location of the next point. This is negative 2, 3. What kind of line is this? It's supposed to be vertical. Undefined slope.
So only when you run is
Actually, the answer to your question is, what did you say?
only if the run is 0 is undefined.
Yeah, do you guys notice rise over run? That means your run is 0. What kind of line is this? Vertical. If you're on that, you're on a cliff and you're falling down forever. That's why I put this sad face. Okay, you guys okay with this? Now, remember, what are you guys doing for homework? You have that worksheet. Is that true? Okay, I'll give you more bookwork tomorrow. All right, see you guys later. Okay, let's go over these problems here. Okay, so part of this was review. Even though we lost the tapes or the video on the intercepts, we're going to review a little bit of the intercepts. And we're going to apply that information from the intercepts to the information for the slope. So I'm going to say to you, on Tuesday we worked on this. On Wednesday we worked on this. So now we're going to put this together on Thursday. Okay, so let's double check. If we're going to determine the intercepts, that implies both x and y-intercept. Right? That's right. So we're looking for both the x-intercept and the y-intercept. So it might be good for you to compare and contrast the work here on the same sort of set of paper here. So if you remember how we do this, this is 4x minus y equals 8. 4x minus y equals 8. So let me remind you guys. An x-intercept, how does that generally look? Isn't that some x value with the y value being 0? How does the y-intercept generally look? 0, comma, with some y value. Okay? So right away I'm going to point out to you that think of this kind of concept, because now if y is 0, what do you guys do here? Plug in a 0 for y. For the y-intercept, what do we let be 0? X is 0. So what you end up getting now is really 4x minus 0 is 8. Do you guys know what happens when I subtract 0 from 4x anyway? Isn't that just 4x? Now 4x is 8. If I divide by 4 now, what do we get for x? So x is the value 2. What that means is 2, 0 is your what? That's the x-intercept. This is the address. These are the coordinates. Similarly, 4 times 0 is going to give you what? Isn't that 0? Minus y is 8. So negative y is 8. you guys remember? What does that mean about y if negative y is 8? Well, could you guys tell me what y is? It's a negative 8. Good. Well, there's two reasons. One reason is, okay, negative 1 times y. Divide both sides by what? Negative 1. Your negative 1s go away. Y will be your negative 8. Okay, remember you guys are on video. They're going to know, I'm not going to mention the name of the college, but people are going to know what college this is. Okay, so let's remember. So x is 0, y is negative 8. This is your y-intercept. Okay, you guys okay with that? That was on Tuesday. Those are your intercepts. Okay, so here we go. What do we do next? We're going to determine the slope. Yeah.
You know how we had to do y2 minus y1? Does it matter? Because I think I put the y-intercept first and then the x-intercept.
Oh, okay, yeah. Yeah, let's talk about that. Let's go with the second question. We're going to have to find the slope of the line that contains these two what? Points. Is that right? You guys okay with that? This is what we're going over. So you're going to need your slope formula, and that's going to be y2 minus y1 over x2 minus x1. So here's the question here. This is how we find the slope, but we have to be given what? 2 points on the line. Do we have 2 points? Yes, we do. One's the x-intercept, the other's the y-intercept. Okay, well, which one's the first point? Which one's the second point? From yesterday, we said, really, it doesn't matter. But I read left to right. So I'm going to call this point 1, point what? 2. I'll use the subscripts. Okay, you guys okay with that? So the next step in the process is this. Here's what you guys want to do. Go back and read this. The first value is always a what? X value. So this is the x value for what point? The first point. So in other words, x1 is the value what? 2. What about the second value? Isn't that always a y value? So y for point 1 is the value 0. This is the x-coordinate, y-coordinate for point 1. This is your x-coordinate, y-coordinate for point what? 2. So that means x2 is what? Is 0, and it means y2 will be negative 8. Okay, so in the process, you're going to go back and you're going to use the slope formula to compute the slope of the line that contains the intercepts, the 2 points. Now what do you guys do with this information? Excuse me?
Why is there a 1 and a 2 on the side?
Because I'm naming my point 1, and I'm naming this point what? 2. Those are subscripts. So I can find these values here. x1, y1, x2, y2. Plug in the values. y2 is negative 8. y1 is 0. x2 is 0. And x1 is 2. So now we get that our slope will be negative 8 minus 0 over 0 minus 2. What's negative 8 minus 0? Is that negative 8? What's 0 minus 2? Negative 2. Negative 8 divided by negative 2, what do you get? Your slope is 4. Okay, so we worked on this on Tuesday, we worked on this on Wednesday, on Thursday we're reviewing both things, but we're going to transition to graphing this, and we're going to use this information in the future. So it's a good, like I mentioned, since we lost this stuff, we have to review it. Anyway, your slope is the value 4. So this is your second, whatever problem here to do. So does anybody have any questions on this slope being 4? Now, this is also kind of review. You're going to have to graph that line by plotting the what? Graph the line really by plotting your intercepts. So you have to, now we're going to review that. How do you plot 2, 0? Remember, this is an x-intercept, so it's going to intercept the x-axis where? When x is the value what? 2. Where is 2 on the x-axis? Is that to the right? Remember, because 2 is positive, so you're going to move 1, 2. This is the location of your x-intercept. And yes, formally the address is 2 comma what? 0. But you're on the x-axis. That's what an x-intercept is. What about your y-intercept? Where's that? 0 what? -8. So if you look at this, we're going to have to go down really how much? Why is it going down anyway? Anybody know? Good, because it's a negative value. Down is negative and up is what? Positive, okay? So we got to go down 8 units. Let's find where that is. 1, 2, 3, 4, 5, 6, 7, 8. Formally, that address is at x is 0, y is -8. Isn't this point on the y-axis?
Yes.
Right? We call this then a what? A y-intercept value. This is on the x-axis. It's an x-intercept. So we're going to graph this line by plotting the intercepts. So you need only 2 points to draw a line. So now you're going to draw your what? You're going to draw your line. So here we go. Yeah. Uh-oh. Let's be a little more careful here. Maybe I shouldn't hold so many markers. So here's the line they're talking about. They want you to graph this line by plotting intercepts. Okay, you guys okay with that? I want you to notice a couple of things though. What do you guys notice about the slope? Isn't it positive? Is this uphill or is this downhill? That's uphill? Okay, so we're going to talk a little bit about this though. Remember, we're not going to go into a lot of detail. We're going to go into detail of this some other day. But I want to point out to you that wasn't a slope a rise over a run? So I need a fraction, don't I? Because isn't that slope a rise over a run? Right? Remember yesterday we said a slope was a rise over a what? Over a run. And then I got a 4. So is that a rise value or is that a run value? Is that rise or is that run? Well, first of all, do you have a fraction? No. How do you turn that whole number into a fraction? Divide by what? So I can look at this as 4 over 1, where 4 is my what? Rise, and 1 is the what? Is the run. Yeah. Well, today you don't. No. In the future, you may. In the future, not if you're just gonna compute a slope using the slope formula. No. Your slope is 4. But I want to point out something interesting to you. That the rise, remember, a rise is what kind of movement? Up or what? Down. So the y-axis is positive in the up direction, is that right? And it's negative in the down direction. So this 4 is positive. Do you guys know what that means? In some ways it means the rise is going up. The run is left and right movement. Left and right movement is horizontal movement. Going to the right is positive. Going to the left is negative, so I want to point out to people that the run is also what? Positive. That means you're going in what direction? To the right. So I'm just going to talk a little bit about the meaning here. We'll go over a lot more detail in the future. But I want to say something to you about the slope and how this works. That any point on this line, we can always generate another point on the line by using the slope information. And you say, what are you talking about? Well, start here at the y-intercept of -8. Okay? If I want to use the slope information to find another point on the line, what can I do from that point of a -8? I'm going to rise 4. 4 is positive, rising is going up. So I'm going to go up 1, 2, 3, 4. Everybody okay with that? We went up 4. We rose 4 units. I'm going to run 1 unit in what direction? To the right, because 1 is positive. Where does that put me? At another point on this line. So what I'm saying to you is, from one point on the line, if you know the slope, you can find another point. And in fact, you can repeat this process forever. I can say, if I rise another 1, 2, 3, 4 points here, okay, this is where 1 is. If I rise another 4 points, or 4 units, I can now go to the right another 1 unit. Aren't I on that line again? And the answer is yes, because here's 1. So in the future, come Monday, when you guys come back, we're going to use this information in a lot more detail. But I just want to point out to you, with 1 point and the slope, what could you do? Find additional points on the line. And that's going to be what we do in the future forever. Okay? But I just want to say to you that there's a purpose for why we're computing the slope and why we're thinking about the slope. There's a purpose for why we're finding the x and y intercepts and why we're plotting it on the line. And you'll see on Monday, we'll put it all together for you. Okay, so this is kind of where you're headed. So today, what are we doing? Finding intercepts, computing the slope with those intercepts, drawing that line with those intercepts. Okay? Anybody have any questions on this so far? Yes?
You have to put n is greater than 0.
No. No. Okay, let's take a look. Can I erase this? You guys have this over here? Okay, we'll keep the graph there for you. Let me erase this other work. Okay, so I'll erase all this information prior. This is 4. Okay, so let's take a look. What was the second question? What was the second equation you had? Okay, let's try that one. Negative 2x plus 7y equals 14. Negative 2x plus 7y equals 14. We're going to follow the same exact process again. Got to find the x-intercepts, the y-intercepts. Okay, so I'm going to say you're going to start with the negative 2x plus 7y is 14, and your negative 2x plus 7y is 14. So I'm going to do this slightly different again. Or maybe it's good that you do notate, you know, how you find those intercepts, right? I used to do this all the time. But then after I notated this, you guys remember that procedure I wrote down for you, right? The procedure is that you let y be 0. So y is 0 here. That's a 0 value for y. And then you solve for what? For x. Here, for the y-intercept, we let it what? What do we let be 0? X is 0, and we solve for y. So I want to remind you about that procedure, even though we lost the video. Here we go. What's the effect of 7 times 0 anyway? Isn't that 0? So what's 0 plus anything? Itself. So what's happening here is that this portion's really gone, isn't it? So pay attention to that. You really now have negative 2x equals what? 14. That's because of the effect of the 0. Similarly, negative 2 times 0 is also what? 0. 0 plus 7y is 7y. The point is that 0 makes this portion go away. And you get 7y is what? 14. Okay? So here we're going to solve for x. Here we're going to solve for what? For y. Divide both sides by your negative 2. You get now x is 14 divided by negative 2 is negative 7. Divide by 7. You get y is 14 divided by 7 is really what? 2. The x-intercept is really going to be negative 7 comma 0. And your y-intercept is 0 comma 2. Okay, so here's 2 points on your line. You really found 2 intercepts for this equation. So if we're going to compute the slope again, what do you guys remember? You got to write every time you use the formula, I recommend you write it down. Because then what you're doing is you're training yourself to remember this particular formula. And this is called, again, the slope formula. Okay, so you're going to write down that slope formula, but notice, how do you use the slope formula? What did you need? You need 2 points. Do you have 2 points? You sure do. Which one's the first one? Which one's the second one? What do you guys think? The one on the left is your first, maybe? The one on your right is the second? Does it have to be? No. I'm consistent. So I'm going to put the first point on the left, the second point on the right, because I read left to right. So, if you guys recall, if this is my first point, what position is the negative 7 in? The x-coordinate position or the y-coordinate? So that means x1 is negative 7. It also means y1 is what value? 0. Good. Everybody okay with that first piece of information? This is the x-coordinate value. Here's your y-coordinate value of the first point. This is your what? X-coordinate value of what point? The second point, and that equals 0. This is the y-coordinate value of the second point, and that equals what? 2. So you do have to go back and look at that information because you got to plug it in your slope formula. Okay, you okay with that? All right, here we go. Let's plug it in. What's y2? 2. What's y1? 0. What's x2? 0. What's x1? Negative 7. Okay, let's see. My slope is 2 minus 0 over 0 minus a negative what? 7. Just because this has a negative sign, ladies and gentlemen, don't think that that negative sign that's already here in your formula takes the place of that negative sign for the 7. It doesn't. So this is a minus a what? Minus. Is that minus a minus? Minus a minus makes this a what? Positive. So your slope is going to be 2 over, what's 0 plus 7 down here? 0 plus 7 is? 7. Good. So your slope is 2 over 7. Notice this. Notice something interesting here. Isn't that 2 a rise value? Isn't this 7 a what? Run value? So this 2 is going to be your rise, and the 7 is going to be your run. All right, you okay with that? Okay, here we go. Remember, you guys are going to be graphing lines for a very long time, so you want to get it right. This is your process. Okay, we're studying the line, finding all these concepts and ideas. We're going to try to use them. Use them to draw the line that represents, what did that, remember we talked about this the other day? We lost the video, but what do those points on that line represent again? What do we call those things? All the points on the line. I know I erased it. We'll go back again. We'll talk maybe a little bit. Good. There were solutions to the equation. Good. So we'll look at that. But okay, let's kind of graph this line here by plotting the intercepts. Where's the x-intercept, by the way? Anyone know? What is it? At negative 7, 0? So the x value is negative 7. Where's negative 7 on the real number line here for x? Well, it's negative, so we know it's where? To the left, how many units? 7. So this is 1, 2, 3, 4, 5, 6. And if we have to extend this, we will. 7. I'm going to say, did you guys get the graph paper? Good. You want to go stop by the 99-cent store and spend how much money? 99 cents on some graph paper. That's only if you like your sanity. Because drawing it freehand the way I'm doing is really not the best thing to do. Okay, you also want to spend another 99 cents on what? On your ruler. That's only if you like yourself. Okay, take a look. I'm a professional, and take a look. I graph lines for a living and I plot them. Don't I need a ruler too? Absolutely. So what about the next point? This is my what? Y-intercept. It's at 0 what? 2. Is that true? Where is that at? Well, 2 is positive. So good. Positive direction for the y-coordinate is up. Positive is up. So we're going to have to just go up how much? 2 units. So now you're free to draw your line. So here we go. Let's draw this line. I call this line. It represents solutions to your equation. Okay, it's solutions to that negative 2x plus 7y is 14. Solutions to this equation are represented by that line. But let's go back again and look at the slope here. Remember we said the slope is 2 and 2 over 7? And what did that mean? You had a rise of what? 2 and a run of 7? What is a positive? Isn't 2 positive? So rising was going up or down. We've seen that yesterday. Positive is in what direction? Up. Negative is in what direction? Down. So here's what I'm saying to you. From any point on this line, and how many points are on that line? Well, there's 2 intercepts, but for the whole line in blue, how many points are here? Do you guys know? What did we say the other day? Infinitely what? Many points. So here's what I'm saying to you. If I pick any one of those infinitely many points on my line, and I use the slope, by the way, you say, what are you talking about? Let me start over here at the x-intercept. If I rise 2 units, rising is up because 2 is positive. So I have to go up 1, what? 2 units. Everybody okay with that? From that point, I went up 2 units. My run is also positive. Run is left and right. Positive direction for a run is to the left or to the right? How do you know it's to the right? Because on the x-axis, going to the right is positive, right? So I'm going to go run to the right. How many units do I run? 7. Take a look at this. 1, 2, 3, 4, 5, 6, 7. Aren't I on that line? And I want to point out to you the answer is what? Yes. So from this location, I can actually plot a second point, happens to be the y-intercept. Just want to point that out because come Monday, we're going to use that extensively. So I want to point it out to you guys now. Okay, you guys okay with this? Just going to point that out. But anyway, this is your slope value. This is kind of how it's thought of and used. Let's kind of give you a little note really quick. Let's note. Let me pick a point that's not on the line. How about if I pick this point, I said, let's go out to the right Oh, how many units? Let's go out 3 units to the right. 1, 2, 3, and let's go up 1. The address is 3, 1. Okay? I know we lost the videotape, so this is why I'm going over this. 3, 1. Is that point on your line? No. What do we say about points that are not on this line? They're not solutions. Okay? Because being a solution is a point that is on this line, and there's infinitely many points on the line. Too many to count. Infinitely many. So let's check. How do we check to see whether that's a solution or not? Well, you plug in the x and y coordinate values in your equation. So here, what's the value of x? 3. Plug in a 3 for x. What's the value of y? 1. So if I plug in 3 for x, I'll emphasize it in red. 3 is x. 1 is y. Let's double check. We get negative 2 times 3 plus 7 times 1 is 14. Okay, order of operations says do multiplication before addition. Negative 2 times 3 is negative 6. Plus 7 times 1 is 7. That's supposed to be 14. What's negative 6 plus 7? Positive 1. Is 1 the same as 14? No, we seen last time, plugging in that point gave us a what? A false statement. That meant that this particular point is not a solution, or that particular point is not on the line. Okay, you guys okay with that? Compare that to, well, what do I know that's for sure on that line? Maybe that y-intercept value, right? What's the y-intercept value? Formal address, by the way. X is 0, y is what? 2. What's the address for your x-intercept? Negative 7, comma 0. Aren't they on our line? So let's check to see what happens when I pick points on the line, like x is 0. And our producer's not here today. Is it good for you guys to miss a day? No. No. You ever notice? What happens if you miss a day? You miss some material. Then you got to catch up. Not so easy to do. Okay, you can read, you can ask somebody questions, hard to do. So you don't want to miss. But anyway, let's go back again. You see that point, 0, 2, coordinates, x0, y2? Plug it in your equation, get a true statement. That means that this is a solution to the equation. Okay, good. So that's a little bit of review of what we did. Anybody have any questions on this one? Did you guys work on that one?
All you gotta do is for x and y to
Yeah, to find your intercepts, yeah. So let's try the next one. Let's see what's interesting about the next problem. Anybody get to do the next one? You still want this up, or should we erase it? Leave it there. Okay. What was interesting about the third one? Yeah, let's see what that one is. Let's see. 3x plus 2y is 8. Okay, we'll go through our process of finding intercepts. X-intercept, what else? Y-intercept. So let's see. You have 3x plus 2y equals 8. 3x plus 2y equals 8. Okay, to find an x-intercept, what do you guys do? Let x be 0 or y be 0? Y be 0, good. Solve for x. For the y-intercept, what is 0? X is 0, solve for y. If you have to remind yourself, is this kind of a good way to remind yourself? X, 0, let y be 0, solve for x. 0, y, let x be 0, solve for y. So notice 2 times 0 is 0, and 0 plus anything is itself. What I'm saying is this is really gone. This is 0. So you have 3x equals 8. So when you divide both sides by 3 to solve for x, x is 8/3. And ladies and gentlemen, the x-intercept is at 8/3, comma 0. You can get a fraction. Okay, now what about this one? All right, 3 times 0 is what? 0. 0 plus 2y is 2y. So 2y is 8. You're going to divide both sides by 2. You get y as the value. What's 8 divided by 2? 4. So 0, comma what? 4 is your y-intercept value. Okay, so here's your review of what we talked about on Tuesday. What happens now? What do we do? Well, which point is your first point? Which point is your second point? Isn't the one on the left number 1 maybe? The one on the right number 2? So let's see if you guys can read this information. Tell me then, see if you're awake, what is x1? What is it? 8/3. Okay, good. What is y1? Good. What is x2? 0. Good. What is y2? 4. All right, you okay with that? So what do you do now? Plug it in. Okay, good. So we have a 4 here. We have a what? 0. We have a what? 0. What do we have over here? Negative 8/3. Is that, well, it's positive 8/3, by the way, when we plug it in. But you may notice that using the slope formula, you get m to be 4 minus 0 over 0 minus what? 8/3. So what is this? Isn't that 4 over, we'll write it here, 4 over negative 8/3? We're going to have to. So can I erase this? You have this already in your notes? Okay, so let's note here that we have some arithmetic to do that, you see, how do you read this actually? You guys remember we reviewed this actually, these fractions, we did some review? This is 4 divided by what? Negative 8/3. So we're going to write this as 4 divided by a negative 8/3. Is that true? In other words, you have a vertical definition of division, and you wrote that horizontally. Now, you wrote it horizontally because you know how to divide by a fraction. You what? Multiply by its reciprocal. You flip this one over. So that's going to be negative what? 3/8. So what do you guys do? How do you multiply fractions? Is that 4 multiplied to the 3? And is that, where's that negative at anyway? Is it top or bottom? Well, it's up to you. You can think that a positive times a negative is simply going to be what? Negative. But then the 4 is going to be multiplied to 3 or 8? 3. What's 4 times 3? 12. That's 12/8. What does this reduce to? Negative 3 over what? Over 2. What does this represent again? The slope. So you have a slope of a negative 3/2. Okay, you okay with this? Now, let me point something out to you. When you go to graph this, sometimes students get a little nervous about this particular type of problem. I want to talk about it because I took it from your homework. Do you guys know that? I took this from your homework. Do you guys know, how do I plot an X-intercept when it's really what? It's a fraction. This is 8/3. Do you guys know, what is 8/3 really going to be? Either. 8/3 is really what? What is 8/3? 2 and what? 2/3. Is that true? So x, or the intercept on the x-axis, is at 2 and 2/3. Here's what? 1. Here's 2. Here's 3. Do you guys agree? 2 and 2/3 is really what? Well, you can think a little bit about this. I know if you had 110 with me, I talked about plotting 2 and 2/3. You know, we've talked about that, meaning I said, okay, 2 and 2/3 is between 2 and 3. What you're going to do is partition your real number line here between 2 and 3 into thirds, 3 equal pieces. So the first piece is 1/3. The second piece is what? 2/3. You can just eyeball it and say, this is where, you know, this probably is. We're going to sketch this line. So we can kind of say this is where 2 and 2/3 would be. It's just a sketch. You can also think and say, okay, 2 and 2/3, isn't that 2.67? Numerically, the answer is yes. Is that closer to 3 or 2? Well, it's 0.67, that's closer to 3. Yeah. Oh, 8/3. And 8/3 is really what? 2 and 2/3. So I have to find where is 2 and 2/3 on that real number line. Some of your homework questions do have these, you know, kind of problems. So 2 and 2/3 is between 2 and what? 3. Oh, 8/3. Let's see, 8 divided by 3 is 2. 2 times 3 is 6. Subtract, I got 2. Here's my remainder. Here's my quotient. It's a mixed number. Everybody loves mixed numbers. 2 and 2/3. I did the division.
You have to do it as a mixed number?
I think that you have to do it as a mixed number if you want to think about what? Plotting it, yes. Everybody okay that 8/3 is 2 and 2/3? Okay, so you converted your improper fraction to a what? Mixed number. Sorry. Yeah, it's a mixed number.
Can we like note that?
You want to put this in a note? It's kind of because we're videotaping this. We're really limited with our board space. It's really bad. So yeah, if you want to notate it, okay. So you get 8 divided by 3, right? 3 goes into 8. Twice. 2 times 3 is 6. Subtract your remainder is 2. Here's my quotient. Here's my remainder. This is what I'm dividing by. So it's Q over R D. Q is 2. Remainder is 2. What you're dividing by is 3. So it's 2 and 2/3. So 8/3 improper fraction is 2 and 2/3 as a mixed number. 2 and 2/3 is between 2 and 3. You cut this into thirds. First is 1/3. Second is 2/3. Third is 3/3, which is 3 or 1. Anyway. That's how you plot what? Oh. That's how you plot what? Fractions. Okay. What about this next, where's the Y-intercept?
4.
At 4. Okay. Whew. Is that a mixed number?
No.
Well, I don't know. Is it? Let's we thought about it. Well, it's a whole number. Okay, good. What do you guys do now? Draw your what? Draw your line. And I vowed not to draw my line carrying all these markers. Do you guys notice something here? Here's my line. I want to talk a little bit about this because this is important for you. Here's the line we drew. Just to point out to you guys, give you a heads up, we got how many more minutes?
5 minutes.
10 more minutes. Huh? This one took long? I know. Okay, you guys ready for some important piece of information?
Yes.
It's going to save your life. It may save you from University of Phoenix one day. Okay? Your slope is negative 3/2. Where does that negative sign belong? I mean, isn't it a negative slope? So we're going how again? Downhill? So what does that negative 3/2 mean as a slope? Well, let's think about this. If that negative sign, where does that belong? Do you guys know? Well, it doesn't matter. It can go where? On the top, or it can go where? On the bottom. Just make sure it's never what? Both top and bottom. Why can't that be both top and bottom? Because a negative divided by a negative is a what? Positive. That slope's negative. So what I'm saying is that you have a choice. You can put that negative sign top or bottom, just not both. So let's say you put it where? On top. Do you guys know what my personal favorite is? To put the negative sign on top. I'll talk a little bit why, but not right now. Now, if the negative sign's on top, isn't this still rise over what? Run? Isn't that rise over run still? What does it mean if your rise, which is an up and down movement, what if your rise is negative? If your rise is negative, what does that mean? You're not going up, because we think rise is always up. Rise is going down. So take a look. If I start from any point on this line, I'm going to start here at my Y-intercept. If I rise down 1, 2, 3 units, I went down 3 units because that's in the negative direction for vertical movement. You okay with that? So I'm going down. Now, what about the run? Run is left or right. The run is positive. Positive 2, right? Is that going to the right or the left? Good, because going to the right is positive for a left and right horizontal movement. So if I go 1, 2, what do you guys notice? I'm on the what? I'm a point on the line. You guys with me on this? So what I want to emphasize to you and leave you with the weekend with, when you do your homework, because I know you're going to, right? It's going to rain, so what are you going to do? You can't go to Vegas because it's dangerous on the road. I want you guys, when you do those problems and you think about this, that what we're going to do eventually is 2 things. You're going to use this concept of rise and run eventually to find additional points on your line. And that's actually going to be the method of choice from this point on, not today, but come Monday, I'll show you how to graph these equations by using what's called the, slope-intercept form. I'll show you where it comes from and how you use it. And this is what you'll do for the rest of your life come Monday. So, are you guys going to miss Monday? No. You sure about that? Should we actually take a row and find out who's going to be here? Should we take your picture? No. And we'll compare the class on Monday to the class today. We'll show the world who's here and who's not here. You don't want to show up every other day. You want to show up what? Every day. Okay, we'll see you guys. Oh, by the way, I'll give you some homework. Adding some questions.
Is it the 3.27?
Okay, let's go over this exercise here. Okay, we're gonna start to use the slope when we draw our lines. Okay, so I got 4 sort of warm-up questions to do. And know you're going through what? They're going to say draw a line through the point P with slope what? M. Here's your slope M. Slope, remember, is rise over what? Run. Okay. So for the first problem, the rise is 2 and the run is what? 3. They're going through the point 0, 4 with the coordinates x is 0, y is 4. Does anybody know, does anybody recognize this point? What kind of point is this, by the way? Anybody recognize the point, 0, 4? What kind of point would that be, you think? If x is 0, remember, y is 4, what kind of point is this? In fact, if you looked at all of them, x is 0, y is negative 1, x is 0, y is 2, x is 0, y is negative 3. So in each case, x was 0 and y is some value. Does anybody know what's so special about these points? What kind of points are these? Good, they're y-intercept values. So I'm going to say through the point, these are y-intercepts. Okay, sometimes for y-intercepts, we like to, since they're so special, we like to kind of describe them as a 0 kind of b, where b is the y-intercept value. So I'm going to transition a little bit here today, show you how this works and why. But we're going to plot each one of these happens to be y-intercept values. Okay? So they're all y-intercepts. Since they're y-intercepts, where is that point? Because you're always going to start with the point. So where is that point here, 0, 4? Where is this y-intercept at? Does anybody know?
On the y line.
It's on the y-axis where y is positive 4, because 4 is positive, right? So we're going to have to look for 4, and it's 1, 2, 3, 4. Does everybody agree that the y-intercept value is right here on the y-axis at 4? Does everybody agree with this? Okay, so it's at 4. Now here's what you're going to do. You're going to start by plotting that point. We're now going to use, as we seen last time, that we can use the slope to find another point on that line. So in this example, the slope is what? 2/3, right? So what does the 2 represent? It's a rise. Now you can either go up or down for rise. Since 2 is positive, we're going how? Up. Good. And you say, why do we go up? Because with the vertical direction on the y-axis, up is positive, down is negative. So we're going to go up 2. Now what about the run? Right? Run is left to right movement. Going to the right is what? Positive, and to the left is what? Negative. So to find the next point on this line, and all you need is what? 2 points. We're going to have to rise 2 and run to the right 3. So let's see how that looks. We're going to go up how much? 2. Is that true? So if I go up 2, by the way, I'm starting here from my y-intercept. I go up 1, 2. Okay? And then I run to the right how much? 1, 2, what? 3. This is the location of my next point. Okay? And yeah, that'll be kind of, this should be 3, I guess. It's not really to scale, but that's okay. But this is the location of my second point on the line. All I need is what? 2 points. I can get a third if I wanted. Not necessarily needed. So let's now draw the line. And there you go. Here's the line we call L. That's all they want you to do. Okay, so you're going to use the y-intercept value. You're going to plot that first, and then use the slope information to get the second point. Okay, does anybody have any questions on what we just did? Is that easy or hard? That's easy, is that right? Okay. Well, let's see. Let me erase this. Let's go to the next one. Okay, what does the next one say? The next one we go with, you're going to draw your x-axis and your y-axis. Okay. So again, we're going to start with plotting the y-intercept. Where do you plot that first point? X is 0, y is -1. Where's that at on the y-axis? Anybody know where's -1 at? It's on the y-axis. Where is it at? Up or down? Down. How much? 1. Good. So this is where you start on my y-intercept. Okay, all of these are y-intercepts. And then how do I find the location of the next point? I have to use my slope. Is that true? Now, yesterday or the other day, if we notice, this slope is what? Negative. So that means we go downhill. The prior example was positive. That means it was uphill. Did it look like it was uphill? All right, what about this negative? Where does that negative sign belong? Top or bottom? I always put it where? On the top, meaning this slope is a -1 over a +2. Okay? That's where I put my negative sign. The reason I put my negative sign on top here is because this is still, by the way, rise over run. However, my rise is now negative. Where's the negative direction? When you're talking vertical. Up or down? Down. Isn't this where the negative direction is? So we're going to go down 1, and then notice the run is still what? Positive. So you're still going to the right, but this time by 2. 2 units. So from this point, I go down how many units? 1. And then to the right, how many? 2. So let's go down 1. If I go down 1, doesn't that now mean I'm at -2? All right, so I go down 1, and then what do? I go to the right how many units? 2. So this is 1. This is another. Here's 2. That's the location of my second point. Okay, start at the y-intercept. Use the slope information. That's a second point on the line. Now what do? Simply draw my what? Draw my line. Now notice, is this going to be a downhill scenario? So is the slope negative? Okay, so this is downhill. Here's my line. And there you are. Okay, does anybody have any questions on number 2? Okay, we're going to start at that point and use the slope to find a second point on the line, and we're going to draw our line. Okay, is everybody okay with that one? Is that easy or is that hard? Well, you're going to have to practice. That's pretty easy, right? So let's do the next one. Anybody have any questions on this one? Nope. Guess we have to use this ugly old eraser. Okay, let's try that again. We're on number 3. Y-axis, x-axis. We're going to start again with our point. This time, what do you guys notice about the starting point? Where on the y-axis do we start? Anybody know? Where do we start? At 2? Okay. At 2 on the y-axis, is that 2 positive? Okay, so we're going to start up here. This is our starting point. This is our y-intercept. Okay. Now, what do we notice? What's the slope? It's 2. Don't I need a rise and a run? Don't I need a fraction? So what did we do last week? Divide by 1. Good. This is still rise. Is that positive? Is my 2 positive or negative? So I have to rise. My rise is up. What about my run? Isn't that positive? So it's still to the right. Here's what I want to point out to you with the prior example. The reason I put the negative sign on top always, personally, Because then that means I'm always running in what direction? Where do I go now? To the right. You guys see what I'm saying? So if the slope is negative, I put the negative value on top. That means my bottom is positive. So even if the slope is positive, I'm always running to the right. So I just have to worry about whether I go up or down. I go up when the rise is positive. I go down when the rise is negative. So this means go up to and to the right what? 1. And where do you go from? What is that point called? What's that point? The Y-intercept. So you're going to go up 2 to the right 1. Up 1, 2. And then to the right what? 1. That's the location of your next point. Okay? Draw your line and you're done. Here you guys go. Okay? Here's your line. Anybody have any questions on this one here? You sure? Let's go to the next one. Number 4. Jeez, all these car alarms all the time. What is that, more than one? Huh? Man, there's still more than one car at a time? That's a challenge. Don't steal one, steal what? 3. I don't know. That's what happens when you buy a cheap car alarm. You always have to turn it off. Don't save money in a car alarm. Okay, do you guys know that already? If you try to save money in a car alarm, it's going off all the time, and you're going outside. Then you're turning off the car alarm. Do you guys know what thieves used to do? They'd set your alarm off over and over again until you got so tired you turned it off. And then they got into your car. Do you guys know about that trick? No? Huh? You never stole a car? I'm talking about having your car stolen, not steal a car. There used to be a trick that guys would do because everybody'd spend money and buy the cheap car alarm. And so you're home having breakfast or whatever, your car alarm goes off every 5 minutes. And you get annoyed and then you turn it off. You go, oh, that dumb car alarm doesn't work. And once you turned it off, when they went over again to try to shake the car to see if it was on, and it was off, well, then they broke in your car. That's how it used to be. It reminds me of that every time I hear these alarms going off. That's all I think of is, oh, okay. All right, here we go. Where's your Y-intercept here? What's this number? Where's -3 on the Y-axis? Is it down? Down how many units? Down 3 units, is that right? So here you are, and then how do we use this slope? Right? It's still a rise over a what? Over a run. So what's your rise like now? You're going up or you're going down? Down 1, and notice this. You see how I kept the negative sign on top? My run is still going to be where? To the right. So ladies and gentlemen, I'm always running to the right. Now, we're going to start at -3, the Y-intercept, and then you're going to do what? Go down 1, and then to the right 1. That's the location of your next what? Point. So you're done plotting 2 points. You now draw your line. Notice, is this a downhill situation? Is that downhill? Here's your line. It's a downhill situation, and the slope is negative. Okay, you guys okay with that? Anybody have any questions on this, what we just did, this exercise here? Plotting the y-intercept using the slope? Is there anything special about the y-intercepts? What do you guys think? In other words, here's what I want to say to you. Can I erase this? You guys okay with that? Well, let me tell you that there is nothing special about the y-intercept in terms of drawing lines at all. Meaning, even though the exercise required us to plot the y-intercept, they could have given you a non-y-intercept. So I'll call this a note. Let's note. They could have given you a point like -2, 3. And let's say the slope will be, what slope should we use? 4 over what? 5. Okay, good. Let's try this out. There is nothing at all special about, just so you know, we can use the same technique. I just have to plot this point. Where's that point at? It's at -2, 3, right? So this is at x is -2, y is at 3. So we go to the left, 1, 2. Go up, 1, 2, 3. That means I'm here. Okay, here's the location of -2, 3. Oh. I think I'm going to need some more what? Some more space. Okay, so here's where I'm standing here. I'm starting at that one point. To get the next point, I use my slope. What do you notice about the slope? Should make it positive or negative? You like positive slopes better? Okay. So that means I rise how many units? 4. Notice I run 5. Is that 4 positive? Up. Is that 5 positive? So let's plot the next point. I have to go up how much from this point? 1, 2, 3, 4 units. And then go over how many? 1, 2, 3, 4, 5. This is the location of the next point. So I went up 1, 2, 3, 4, went to the right 1, 2, 3, 4, 5. X-axis, y-axis. I get to now draw my line. There you are. Okay? So I want to point out there's nothing special about using these y-intercepts, although it's going to be a major part of your graphing technique. Just wanted to point out you could use any point, here -2, 3, and you could use your slope and you could plot the next point. Okay? So you now have 2 points to draw a line. But let me go through sort of something now. Let's transition. Let's transition to why we use really the y-intercept. Okay, because this gives us a technique for graphing. Okay, so I'm going to say to you, let's note the following scenario. We called 0b, we said that's a general sort of form of a y-intercept, 0b. You guys okay with that? It's so special they give it another letter. They call it b. Okay, the y-intercept is so special. And then I'm going to say to you, and then we have another general point called xy. Okay? So note, I have a y-intercept and I have another point on the line. This point is arbitrary, and I want to point out that this is an arbitrary point on my line. Okay? The thing we've been calling out. So I want to point that out. And then I'm going to say to you, let's consider the slope formula. What was the slope formula, by the way? Last week, you guys did your homework. What's the slope formula? y2, good, minus y1 over x2 minus what? x1. Okay, so I'm going to take the slope formula, and I'm going to consider a y-intercept value and an arbitrary point on the line. Which one is my first point? Which one's my second point? Well, how do you read it again? Left to right. So I'll call that my first point. I'll call that my second point. You guys okay with that? Okay, so now let's actually use the slope formula and plug these things in. Remember, this is my x-coordinate of my first point, my y-coordinate of my first point, my x-coordinate of my second point, my y-coordinate of my second point. What I'm saying is, what is y2? Y2 is just the letter what? Y. Okay? What is y1? Well, y1 is the letter what? B. So let me do it this way. I'll say replace y2 with y, replace y1 with b. Let's see what's x2. Oh, it's just the letter what? This is just my x. And what is x1? x1 will be 0. So when I plug these things in, I'll get my slope m to be y minus b over x minus 0. So do you guys know what is x minus 0? Be careful. If you got $100 and I take away nothing, how much do you have? Okay, so it's still going to be x, right? So you get m to b, y minus b over x. Here's what I'm going to do. I'm going to solve for y. If I solve for y, this variable, I'm going to multiply both sides by x. Is that true? So I have this m equals y minus b over x. Multiply both sides by x. What happens with these x's over here? You guys know? What happens with the x's if it's on top and bottom? It's what? Cancel. Good. You now get mx equals y minus b. I'm almost there. I'm solving for y. What do I need to do now to solve for y? Translate my what? My b. Move the b term on the other side. If I do, I got negative b on the right. What's it going to be on the left? Okay, good. I got mx now plus b equals y. I got a triangle equals a right, or what is this? Triangle equals a square, or what? Jennifer Lopez is who? J-Lo, or I can say what? J-Lo is Jennifer Lopez. Do you guys know what you're looking at? This is the infamous, what is that again? See, the m is what? Slope. Is that true? So this is the infamous, I'll put it down here, slope. And then what is this? The y-intercept? Well, we just say what? Intercept. This is what we call the slope what? Intercept form. That is your new best friend. The slope-intercept form. Slope for m, b for intercept, really y-intercept, not x-intercept. It's the y-intercept. We also call it the what? Y equals mx plus b form. So when you guys take a shower every morning, I think it's good for you to sing the what? Y equals mx plus b song. You just sing y equals mx plus b because, ladies and gentlemen, from this day on, for the rest of your life, when they want you to graph linear equations in two variables, this is what these are. You're going to be given the statement to graph something looking like this in some way, ax plus by equals c, where a, b, and c are real numbers. Okay, your variables are x and y. This is the general form of what we call a linear equation in two variables, the graph of which is a, I'm going to put this in red, the graph is a line. So they're going to say to graph this thing, it's really going to be a line. So for example, they can give you something that looks like this. They're going to say graph 2x plus y equals 3. Okay? So forever, 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 what are you guys going to do? You're going to use what's called the slope-intercept form to graph this equation. No more plotting points like you did in 110. Let x be 0, 1, and 2. What's y going to be? This is your technique forever. So if you take intermediate algebra, they want you to graph a line, you're going to follow this technique. You take pre-calculus or college algebra, they want you to graph a line, you're going to follow this what? Technique. You're going to take calculus. They want you to graph a line, you're going to follow this what? Technique. You're going to take calculus 2. They want you to graph a line, you're going to use that technique. It's that important. Okay, so you want to spend your time and energy doing this, but if you notice, is this in y equals mx plus b form? No, this is in your what? General form. Is that true? Or standard form. Also known as standard form, general form. So what do you do? Do you guys know? What do you do then? Go back to the worksheet called formulas, where you had to solve for a variable, or the homework that you solve for a variable. You always solve for what? For y. And in this example, you got 2x plus y equals 3. Solving for y. Can you guys tell me? How do you solve this thing for y? You got to get y by itself. What's next to y? 2x, and it's added to y. Is that right? So remember, if you had anything added or subtracted to it, you can always what? Translate. Good. Move the 2x to the other side. So on the left, I still have my y. On the right, what happened to the 2x? It's negative what? 2x now. It switches signs, right? Your 3 is still there. I didn't move my 3. What sign belongs to this 3? Isn't that positive? Isn't that 3 positive? Ladies and gentlemen, you are in, what's the name of that song again? Y equals what? mx plus what? b. If you want to, even make a dance for that. When you're singing, you even dance the y equals mx plus b song. Okay? You guys think it's silly, but will it help you remember this? Hopefully. Okay? Anybody have any questions here? Isn't this in y equals mx plus b form? How do you know it's in y equals mx plus b form? You're going to use your eyesight. What do you see? Y equals, a number times x. What's that number? This is my slope. This is m. In other words, my slope here is really negative 2. You guys okay with that? Now what is this number? This plus 3. This is my what? That's my b, my y-intercept. So in other words, this b is the value 3. This is all the information you need to draw your what? Line. Whew. So this is the b value. Okay, you're using your eyesight. Y equals some number times x. That number is m plus that value will be your b. And yes, I know you may say, oh, Mr. Judge, isn't this actually 0, 3? And the answer is what? Yes, it is. What can you guys do with this now, this information? You can now graph in the same way we did those first 4. You guys like that technique? Isn't that better than playing your Xbox? It's a lot better. Here we go. You like that better than your Xbox? So let me erase this for you. We could get started on all these. Here we go. Okay, here we go. How do you guys solve this for y? You got x plus 2y. So what's happening to y? 2 is being multiplied to it. What else? You got this x being added to twice y. So what do you guys do first again? You guys remember when we solved for y in the formula worksheet? Translate your what? Translate x, good. And you get now 2y equals, that x on the left is now what on the right? Minus x, and that 4 is still what? Plus 4. You guys okay with that? Now what do? You're almost there. You got to get y by itself. What do? Divide both sides, okay? This sum is on the other side. You got to divide the sum by the same number 2. Your 2 cancels here. What I want to say to you, though, is what happens with this 2? This 2 is dividing a sum of 2 terms. So that 2 is going to divide what? Both terms. You got minus x over 2 plus 4 over what? 2. Okay, you okay with that? Now we get y equals negative x over 2 plus 4 over 2. What does this mean? What number is that negative sign really representing? Not 1, but what? Negative 1. You okay with that? So here's what this means. You have y equals, see this fraction? Write it as negative 1 over 2. Negative 1 over 2 x plus, what's 4 divided by 2? Is that 2? What's your slope? Is this in y equals m times x plus a what? B? What do you guys think? So m is going to be negative 1/2. And what is b? Positive 2. So when I graph this, what do? Right, where's your y-intercept at? Positive 2? So on the y-axis, I look for positive 2. It's right here on my y-axis. Okay, now I use my slope. Well, that's a negative sign. Where do I usually put the negative signs? I should say not usually. Where do I personally always put the negative sign? On top. Do you guys know why again? Because that means I always run to the right. Good. So from my y-intercept, I mean I have to go now down how much? Down 1, and then to the right 1, 2. Location of my next point. And if I wanted, I could do it again. Down 1, to the right 1, 2. And like I said, I'm not the best artist. I draw my lines freehand on the board. I would love to design a whiteboard that was all Cartesian coordinates. Here's my line I call L. Okay, you guys okay with this? You now could go home and do how many problems? Huh? What if they did this to you? Let's give you another example. What if they gave you y equals x plus 3? What do you guys notice about this problem? Huh? Why are you guys happy about this one? It's already, what is it in? You guys are happy because this is in what? Y equals mx plus b form, slope intercept form. Okay? However, you may tell me, Mr. Judge, I don't see a value for the slope. What am I going to say to you? What is it? Anybody know? The slope is always a number. It's never a letter. Don't tell me the slope is x. If you tell me the slope is x, uh-oh, that's wrong. Slope's a number. It's the number multiplied to x. You may look at that and say, I don't see a number multiplied to x. Well, isn't it true that 1 times anything is itself? Okay, so now your slope is 1. Your y-intercept is 3 still. So I'm going to put down here, my slope is 1. Y-intercept is still 3. Well, slope is 1. Doesn't it have to be a fraction, a rise over a run? What do you divide by? Good. So can you actually draw your line plotting this information? Okay. Okay, let's use this information. Where's your y-intercept at? 3. Okay, where's that? Is that positive 3 still? So that's up 1, 2, 3. Here's where I start. Here's my y-intercept. Okay, and now what do I use? 1 over 1. That rise is positive, so that means I go how? Up 1. That run is positive, so that means I go how? To the right 1. So I'm going to go from the y-intercept up 1 to the right 1. Do I need to draw another point or plot another point? No. Can I if I wanted? Sure. Up 1 to the right 1. Draw my line. Is this easy or is this hard? It's easy? Then maybe you guys can tutor my calculus students. Okay.
It's not policemen around there.
Huh?
There's no policemen around there.
Did the police catch these guys out there?
Yeah.
Sound like it. I hope so. No more car alarms? Do you guys know what it is? It's because we're next to the parking lot. And yeah, I guess next to the parking lot, it's not the best place to have a class. Because people do all kinds of stuff. They put their music too loud. And then the car alarm goes off. And sometimes it's the music and the car alarm. Oh, man. You guys don't like peace and quiet? Huh? Do you guys like peace and quiet, or am I the only one? Probably the only one. You like it quiet? Oh, isn't that the best? Yeah, I know. When you guys go home, is it quiet or is it noisy? It's noisy? Oh. Well, next year, he or she'll be 3. And then she'll be a lot nicer and sweeter. Because girls are what? Girls are, huh? They're not evil. Girls are what? They're bossy? I guess you could say that again. Oh, Jesus. No, they're kind of sweet. Don't you guys think girls are sweet? No, they're not sweet? Little girls are sweet? My daughter's sweet. When she wants to be. Huh? Which is usually all the time. She's always sweet. Girls are the best. Daughters are the best. Okay, we're going to graph this. Let's see what we do. Is that in standard form or slope-intercept form? Standard form. We got to solve for y. Is that right? So if we have to solve for y, how do we do this? Translate the what? 3x, move it on the other side, and notice what you get. We still have a negative 2y. That 3 on the left is positive. It's now going to be what? Negative. And then I got this minus 6 business. Okay, you okay with this? Now what do I do? Divide both sides by negative 2. So cancel your negative 2's. You get y to be negative 3x over negative 2. And I'm going to do something here. You guys may say, what's going on with this? Well, I can say plus a what? Negative 6 over negative 2. You okay with that? So even though that's negative, I'm going to say addition of a negative is still subtraction. Maybe you like that, maybe you don't. We'll see why. Now what happens over here? You got negative divided by a negative is a what? Positive. So you have y equals 3/2 what? X plus, what's negative 6 divided by negative 2? 3. So isn't it positive 3? So it's still going to be plus what? This is 3. So you got plus 3. Okay. What do you guys think? What's your slope going to be? 3 over 2. What's your y-intercept? So I'm going to put my slope is 3 over 2. My y-intercept, boy, I don't know. The number 3 showed up a lot today. So I'm going to start. Where am I going to start at? What do you guys think? Where do we start at? What value on the y-axis? 3? Okay. 1, 2, what? 3. So we start on the y-intercept, and then we use our slope. Slope is positive. 3 over 2. That means the rise is what? 3. I go up how much? 3. 1, 2, 3. And run. 1, 2. It's the location of the next point. So I rose 3 and I ran 2. There you go. What do you guys think of this one? Is that in slope-intercept form? Huh? What do you guys think? Well, what number is multiplied to x? Well, be careful. It's not 1. What is it? Is it negative 1? So I'm going to say that my slope is negative 1. But the question is, what is my y-intercept now?
0.
It's 0? How do you know? How do you know it's 0? I don't see a value for b out here. How do you guys know that the y-intercept is 0? Huh? Because you're smart? Because you're all girls, that's why. And girls are what? Smart. Are they smarter than boys? All right, so what do you think? Isn't that plus what? 0? Can I put a plus 0? So my b is really what? 0. If you don't see a value, doesn't that really mean b is 0? Okay, good. So here we go. Do you guys know what does it mean to start where b is 0? Huh? Where's that location on the y-axis? Where is b is 0? Positive numbers are above, negative are below. It's right here. This is where B is 0. Is that true? Okay, you guys okay with that? That's a very special situation. Now my slope is a -1, but you guys already know I have to have a rise and a run. So that's -1 over what? 1. So my rise is actually down and my run is still to the right. So from this location of the y-intercept, I have to go down how many units? 1, and to the right what? 1. I can do this all day long. Down 1, to the right 1. Down 1, to the right 1. So I could generate points and draw my line. Hopefully, again, I do this freehand. Not so easy to do freehand. Yeah. Here's your line. And that's easy, is that right? Should we do a hard one? Huh? What do you guys think? Should we do one that's hard? Do you guys like this graphing technique? No? You guys know what I find teaching beginning algebra? Not everybody likes doing this. And sometimes what people do on a test is they'll go back to their old Math 110. And they'll try to plot points like let x be 0, x be 1, x be 2, and then find the corresponding y values instead. No, you can't do that. Oh, that's a 5. It's not an S. Yes, it's a 5. So what I'm saying to you guys, you really want to learn this technique because that if you go and you try to plot points in the future, you go to Math 125, intermediate algebra, that's not going to help you. I mean, you should know how to plot points, but graphing lines is so simple and fast. Take a look at this. Look at this. Oh, I got to solve for y. This is in what? Standard form. Look how fast you can do this. Okay. I get 5y is negative x minus 10. Divide both sides by 5. Okay. 5's cancel. I get y equals, negative x over 5 minus 10 over 5. You know, if I do that funny thing Mr. Judge does, he does that plus a negative 10 over 5. I can still do that. Subtraction is addition of a negative. Oh, what number's in front of that x? It's a 1. So what I think to myself when I do this, I'm like, okay, y is negative 1/5 x plus negative 2. Oh, that's really, y is negative 1/5 x. Addition of a negative is my subtraction. Okay, this is the first time I've seen today a negative. Well, that's plus b, is that right? So today I got a plus b business. I got my slope of negative 1. What's my slope again? Here's my slope, my m value, negative 1 over 5. I like my negative on top. And then b here, I can say this is my b. But what I'm really saying, when I do the addition of a negative, that's like plus my b. So I'm deducing this plus b business. Oh, my b value is really what? Negative. Okay, it's a negative 2. So this is the kind of stuff I go through in my head as I do the work. Okay, and then what I do when I have to graph this is draw my Cartesian coordinate system. X and Y. Okay. I start with my y-intercept. This time it's where? Where's that y-intercept at? Down. Where at? Is it at -2? Okay, it's at -2. And then what do I do? Whoop, I have a rise. My rise is actually going down. My run is still to the what? To the right. So I go down 1 and to the right 5. Go down 1 to the right, 1, 3, 4, 5. Yeah. Yeah. Think you guys see how I need my ruler? Okay. That's my line I call L. Notice the slope is negative, it goes downhill. It's a negative slope. You do this all day what? All day long. Easy or hard? It's easy. Should we make it nice and hard? Should we give you like an algebra question? Because you know it's not really algebra until it's really hard. What do I mean by that? Okay, let's look at this example. Graph I got to solve for y. Do you guys know what I see here? I see a negative y. So you know what I'm going to do? I like translating so much, I'm going to do a double translation. I'm going to move my y to the other side. I'm going to move my 1 over here. Anybody know why I'm doing that? Well, let's see. If my 1 on the right is positive, what's it going to be on the left? Isn't it negative? Here's -1. I got -3x over here. You see this negative y on the left? Move it on the other side. What is it now? Just a y. Is that right? Now what do I get to think of? J-Lo. Thank you. Jennifer Lopez is J-Lo, or J-Lo is Jennifer Lopez. Actually, I got to get rid of that J-Lo business because J-Lo's old news. Who cares about J-Lo anymore? Who should we use? Not if it's not J-Lo. Who? Oh no, forget it. Not Kim Kardashian. Oh gosh, forget it. Oh, you guys want me to read something, you guys, after we finish this problem? I'll read something. You're thinking of Kim Kardashian. What's my slope? -3. What's my y-intercept? -1. Good. Oh, if it's negative, divide by 1. Rise and a run. Okay, what do you guys plot first? Where's your y-intercept at? -1. Where's that at? Down. Here's your y-intercept at -1 on the y-axis. And then what do I do from this y-intercept? Down 3 to the right 1. Let's see. 1, 2, 3 to the right what? 1. Hold on. What time do we get out of here? In 5 minutes. Good. I got 5 minutes. Okay, here we go. Here's your line. You've graphed these. How many examples did you guys see today? I'm just curious. A lot. And I still have to show you vertical lines and horizontal lines. They haven't changed from Math 110, by the way. Okay, so what I'm going to say to you guys today is work on that worksheet for graphing. It's called graphing. I'm even going to give you some book work. Okay, I'll even give you guys some book work. Anybody here have their book? You don't bring your book?